This is lesson 2.3, conditional statements and more definitions of geometry. A conditional or if-then statement is a statement containing two clauses. One starts with an if, and the other one starts with a then. So if we want to make the following statement into an if-then statement, the original statement is the team that scores the most points will win the game. To make this if-then, we'll say if a team scores the most points, then they will win the game. Pretty easy. So now if we want to find the converse of a statement, the converse is a statement formed by reversing the two parts of the conditional statement. So we reverse what comes after the if and what comes after the then. Here's an example. If your pet is a dog, then it is a mammal. After if, we have your pet is a dog. After then, we have it is a mammal. So if I reverse these two parts, like so, we would say if it is a mammal, then your pet is a dog. One problem with that is this word it. It, we can't say it before we talk about what it's referring to. So it refers to your pet. So what we want to say for the converse, if your pet is a mammal, then now we can use the pronoun it. Is the. Alright, now is the second part true? If your pet is a mammal, then it is a dog? No, there's many different pets that are mammals that are not dogs. So the converse is not true. So the converse sometimes is true, sometimes it's not true. A biconditional is a statement in which the conditional statement and its converse are both true, and they're combined into one statement. When they're combined into one statement, we say if and only if. It's a little strange. So if we want to write the biconditional statement for the following if-then, so the basketball team that scores the most points will win the game. We just did that right here. So let's take what we had here. That's that's the conditional. To say that both of them depend on each other, what we say is the basketball team that actually, let's take out that, because that's not going to make sense. We're going to say that the basketball team that scores the most points will win the game. So to make that into a biconditional statement, we'll say the basketball team scores the most points if and only if they win the game. The basketball team scores the most points if and only if Now what this says is it goes in both directions. It's saying the basketball team scores the most points. If their team scores the most points, then they'll win the game. It's also saying if they win the game, then the basketball team scores the most points. So this is a way of, when we throw if and only if between two clauses, we're saying that one depends on the other and the other depends on the first one, and they're both going to be true. Oops. Now, a counterexample is just an example that proves the statement false. So if we want to find a counterexample for this, if your pet is a mammal, then it's a dog. The counterexample could be a cat, or any other mammal that you have that's a pet. But the one thing it couldn't be is a dog, because the counterexample has to prove this statement wrong. So now we're going to just move on to more geometry terms. A right angle is an angle whose measure is 90 degrees. We would do something like this. That's a right angle, and usually they denote right angles by making a little box, a little square in the corner. Oops, I'm drawing all over the place here. That's much better side. There we go. So that's a right angle, and that means that it's 90 degrees. An acute angle is an angle that is less than 90 degrees. So if I do that, and that's definitely less than 90, because 90 would be straight up. Now we move to obtuse angle. An obtuse angle is an angle whose measure is greater than 90 degrees. So if I go out here, the angle from here to here has to be more than 90 degrees, because 90 would be straight up. So that's greater than 90. Now the midpoint of a segment. This is a little tricky definition. It's written in the if-then form. If x is the midpoint of AB, then x is a point on AB, such that AX is congruent to segment XB. Might be confusing, but let's try to draw this out. So we have a segment. We're going to name this segment AB. Now, if x is the midpoint of